Hello, good day everyone. Welcome to De La Cruz Engineering videos. So in this video, we'll be solving a random password problem on structural engineering and construction. So to be specific, this topic will be involving strength of materials and mechanics. Okay, the deformation and the beam deflection. So you can check this problem CE board May 2018, no? If I am not mistaken. All right, so let's start to solve these problems. Okay, so to stiffen the footbridge shown, a short post BD supported by steel cable ADC is added. The maximum tension in the cable is 2 kilonewtons. We have here the dimensions, the modulus of elasticity. Okay, for part 1, what is the maximum weight of a person can the footbridge support? For 2, we have here the W given, the resulting force on short post BD naman. For number 3, what is the total elongation of the steel cable? Okay? So actually, this is a very simple problem, but of course, pag baguhan tayo dito, parang ma-intimidate tayo sa figure, no? But anyway, this is very simple lang talaga. Okay. Before that, we have here the free body diagram. So as you can see here in the original figure, we have here a pin support and the roller support at C. So dapat yung ating free body diagram, this will resist horizontal and vertical translation. So dalawa siya. But anyway, the horizontal reaction at A should be equal to 0 since wala namang horizontal force involved here. Yung weight natin, of course, that will be a gravity load and dapat that is going downward vertically. All right. So by symmetry, we can have here the vertical reaction at A must be half of W, and also the vertical reaction at C must be half of W. Okay. Now we can solve that since given yung ating maximum tension, we can analyze this one. Assumption natin dito, the members here are actually loaded. Okay, so by parang truss lang, no? Truss analysis, by method of joints at joint C, we can analyze this one as this one. Okay, these are the forces involved at joint C. So we have here the tension on the cable. So of course, tension should be going away from the joint, no? We have here the reaction, that is 0.5 of W, and let's call the force on member BC as H. Okay, so logic naman, no? Dapat yung H natin is going to the right because tension is the horizontal component of the tension is going to the left para kontrahin niya. Well, anyway, hindi naman required sa problem to calculate the force on member H. Okay, so if you have the value of tension, which is will be using the maximum tension given, by equilibrium, we can calculate the W here, no? The maximum W that the footbridge can support. Okay, so let's solve this one using the MATCAD. So, ito yung mga givens natin. And by the way, the maximum tension is equivalent to 2 kilonewtons. Alright, so for part 1, again, by considering this analysis at joint C, we can say summation of forces vertical, no? Summation of forces vertical is equivalent to 0. Alright, so we have here vertical forces. Unahin natin itong W. 0.5 of W must be equivalent to the vertical component of T, that is, and of course, we'll be using the maximum T. T max, sine of the angle. So, wala pa tayong angle dyan. Let's say angle theta. Now, angle from the horizontal. Okay? So, we'll be needing this angle theta. So, the angle of theta here can be solved using the dimension L3 and L2. Alright? So, by the way, no? If you notice, dito tayo sa joint C nag-analyze. Pwede rin naman sa joint A. Actually, the same lang sila, no? Because the horizontal component here is 0 lang naman. Okay? So, dito sa joint C lang tayo. So let us solve first the value of theta. And yung theta there is actually arctangent of, we have here opposite L3 over the adjacent L2. Alright, so wala pa tayong L3 dito. L3 is 0.9 meters. Okay, given yan kanina. Is it correct? 0.9 ba yun? Okay. So, in this case, we already have theta. We have T max, 2 kilonewtons. Then, solve na natin yung W. W there is equivalent to, divide natin by 0.5 or actually multiply natin by 2. The same lang yan, no? W is in newtons. This is our answer. Okay. So, yung hinahanap dito is the maximum W that the footbridge can resist. So, actually, any value lesser than this one would be correct, no? Any value lesser than 1264. But, for the problem, maximum weight. So, dapat maximum niya is 1260. But that must not exceed the 1264, no? I hope you are getting that one, no? Dapat hindi siya lumagpas sa 1264. Because if lumagpas siya, then magpa-fail na yung ating footbridge. Alright, part 2. For part 2, we have here given W. So if W daw is 800 newtons, what is the resulting force in the short post BD? Okay, so short post BD in this case. So again, sa assumption sa problem na ito that the members are actually loaded, so we can also analyze a method of joints at joint B. All right, at joint B. So these are the forces involved here. Now we have the weight. We have the force on member BD, FBD. Of course, these forces will not be involved in calculating BD. Now, as you can see, by summation of forces vertical, W is equivalent to FBD. Okay? Ganyan siya ka-simple. So, force on post BD is equivalent to W, which is equivalent to 800. Okay, parang mahirap sa problem but this is very simple. So 800 newtons. All right, so part 3. The elongation, the total elongation. So remember that the formula for elongation, delta, ano yun? We have here P L over A. Ito yung formula ng elongation natin, no? So we can analyze one segment lang, then i-multiply natin by 2. Okay? It can be this segment or that segment. The same lang naman sila. Okay, so yung L natin dito, that should be the length of this cable. Pwede rin natin kunin yung total length niya, then that would be the, hindi pala because iba-iba yung, may tension sila each. Okay, so define muna natin, no? We have here the area, 113 millimeters squared. Okay, so what would be the value of P? So sinabi niya dito, maximum tension yung gagamitin natin. So the maximum, the P is equivalent to T maximum. And that is, in newtons, 2,000 newtons. Alright, now what would be the value of L? Tatlong M ata dyan. Yung L natin, that would be square root of L1 squared plus L3 squared. In millimeters tayo, convert natin. So that would be L3 because we are only considering this triangle here. Alright. And then we can calculate the total deflection. Denote natin siya as total. Equivalent to PL over I. So we have all the givens there, no? And multiply natin by 2 because consider natin yung total elongation in millimeters. So the answer should be 0.504 mm. Alright. Very easy, no? Part 1, part 2, and part 3. Now let's have another example. Another example. To prevent the deflection of the cantilever beam shown, its free end is attached to the tension rod here. As you can see, we have here the length, we have the W, the flexural rigidity EI, and compute the maximum deflection of the beam before attaching the tension rod. Okay? So, let me just input the datas muna, no? Okay. So, ito yung datas natin, by the way. I-move ko lang para hindi siya mag-add overlap, no? Ito yung datas natin. Alright, so for number 1, the maximum deflection, tatanggalin muna natin yung tension rod, no? Yan yung sinabi sa problem. So, if tatanggalin natin yan, if this is our neutral axis, then because of that W load, of course, magde-deflect siya. So, imagine ito yung ating elastic curve. And the maximum deflection will occur, of course, at the free end. Klarong-klaro naman siguro, no? So, maraming methods dito. And let us derive, no? Let us derive a basic formula for cantilever beams. Deflection on cantilever beams. That can be derived easily by using the area moment method or the conjugate beam method. So, i-draw natin yung area moment diagram. So, refer ako sa point A. Dito ako mag-refer axis, no? So, the moment diagram here is due if ito yung ating reference, the moment diagram here is due only to the W, no? Because of the W. So, ito yung moment diagram natin. So, the moment here should be the W times L times half of L. So, that is WL squared over 2. And that should be a second degree parabolic spandrel. Alright? So, para makuha natin yung maximum deflection dyan, this area, i-multiply natin by the location of the centroid to that specific point, then that is the deflection at the free end of a cantilever beam, no? So, if this is a spandrel, then this must be 3L over 4 or 3/4 of L. Okay? So, again, the area of this one multiplied by the moment arm, then that would be the maximum deflection at that free end or cantilever beam. So, i-derive muna natin para ma-recycle natin, no? And I suggest if you are preparing for the board exam, dapat mas maganda if memorize natin yung mga common formulas for deflection of cantilever beams because that is very useful para mas mabilis tayong mag-solve. Okay? So again, the maximum deflection, let me just denote this one. Deflection due to W. Ilagay ko lang due to W, no? At free end. The maximum deflection due to W. Equivalent to, again, the area. Ano yung area nito? Parabolic spandrel, that is 1/3 of length times eto. Dimension dito, WL squared over 2. So, let me just derive first the basic formula over 2. Okay? Again, i-multiply natin siya by the moment arm 3L over 4. Over 4. Or 3/4 of naging 3/4 of length. Okay, so what will be the come up? That is WL squared over 8. WL cube, no? WL squared times L cube, no? Then cancel yung 3, then that would be WL squared over 8. Delta due to the uniformly distributed load, that is WL cube over 8. And by the way, dapat may EI yan. Okay? May EI tayo dyan. Hindi ko na lang siya nilagay dito, no? That should be multiplied by 1 over EI. Alright, so we have here the given. So actually, we can directly solve that using this formula. Okay? Deflection, lagay natin, no? Deflection at free end due to a uniform distributive load. Okay? Distributed load W. Now, using that formula, W, ito yung maximum natin, of course, no? Copy ko lang. And, MathCAD ito, kayang-kaya ni MathCAD yung ating, what we call this, yung units. So, kayo na lang bahala sa units. Alright, bakit walang unit yung lumabas? Maximum deflection, dapat may unit yan, no? WL cube over 8EI. L fourth pala, sorry. Dapat L to the fourth. Correct ba? L to the fourth. May L pa pala tayo dito, guys. Ito, may L. No, L times L squared times L. Alright, so in millimeters tayo. 8.1. So that is letter D. Okay. Okay, for part 2, if the resulting tension in the rod is at 3 kilonewtons when attached to the beam, compute the moment at the fixed end. Okay, very simple. If may tension daw tayo sa rod, here, okay, kinat natin, so tension away from the joint, then what would be the moment at A daw? So that moment at A is the, what we call the reaction at A, of course, no? Sige. So, part 2, sa equilibrium condition lang, no? Part 2, by equilibrium, we can say, let's say, summation of moment, no? Must be equals, let's say, summation of moment at A must be equals to 0. Okay. Let's say positive, counterclockwise positive or counterclockwise is equals to clockwise moment. No, we can say that. So let us say that the moment is clockwise. Clockwise moment is the moment at A. W, because of the W that is clockwise moment rin, and actually yung moment due to the W is WL squared over 2. No? WL squared over 2. Ito yung moment niya because of that W. Now, the moment of this T that is counterclockwise equivalent to T multiplied by N. Okay? I hope that is clear. So, we can solve our L here. Yung ating MA. And, ilagay muna natin yung T natin equivalent to 3 kilonewtons. Okay. So, i-cross multiply, transpose na lang natin, that would be TL minus this one. Okay? So, what would be the value of MA? Kilonewtons meters. Bakit 0 siya? Kaya lang ha. Gawin daw nating newtons. I think 0 talaga siya because may 0 sa choices natin, no? Okay, so that is the answer. Equal lang yung maidudulot niyang moment, either a T and the W. Okay? Sige. That is the answer. 0 yung moment niya pag tension natin is 3 kilonewtons. Alright, how about part 3? Find the tension in the rod to eliminate the deflection at the free end. Okay, so mas maganda gawin na isa-isahin natin. 'Di ba, we have the deflection due to the W, now which we derive. Now, let's calculate the deflection due to the force, concentrated force at the free end. No? So, we can derive that one. Okay. As you can see, because of this force T, iaangat niya yung ating beam para maging 0 yung deflection. Magiging ganyan. No? So, the moment diagram due to this force T is a rectangle, no? Triangle. So the moment here is PL. Okay? Then again yung deflection of the cantilever beam is just the area of this one. Multiply natin the moment arm towards the free end, no? So that is first degree, then multiply natin. If this is triangle, then that must be 2/3 of L. Okay? So i-derive muna natin part 3. We have here let's say deflection due to the concentrated load P. Let me just call this one at P, no? So that would be the area 1/2 of L times PL. Generalize natin, P yung tatawagin natin siyang P, times the moment arm na 2/3 of L. Okay? Of course, divided by EI tayo dyan. And simplifying that one, delta P, because of the concentrated load, that would be PL cube over 3. Correct? Cancel yung 2 natin. That would be PL cube over 3. May EI yan. Alright. Due to concentrated load at free end. Okay, so I suggest memorize these formulas para mabilis tayo. So dinerive lang natin para makita nyo saan galing. Okay, so take note that let me just copy this one. Take note that we have this formula there. Lagay ko lang, no? Ito, may formula tayo because of the uniformly distributed load. Copy ko rin to. Ito. So, pwede natin gawin yung superposition method. That would be a deflection downward. Okay? The deflection downward, that is because of this uniformly distributed load. Must be equals to the deflection or minus the deflection upward equivalent to 0 para ma-eliminate yung deflection natin. Okay? So, let me just copy this one. Ito yung okay, generalize ko muna. That would be deflection due to the uniformly distributed load, that is downward deflection minus the upward deflection, which is due to the force P acting at the endpoint equivalent to 0. Okay? Ito yung ating main equation. Then we want to calculate the value of T. And T yung T na P na gagamitin natin dito, that would be the value of T. Okay? So, let me just say the given equation should be equivalent to ito, delta W is equivalent to ganyan. Okay? Ito yung delta W natin minus tension. Then, i-change ko siya into tension para specific, no? Dapat equivalent siya to 0. Okay? So, ship solve, I will just guess a value there. Let's say 1 kilonewtons. Okay? So, sa calculator ship solve na ito, so, find the value of T equivalent to 250 newtons. Or gawin natin kilonewtons at is 2.25. Letter C. Alright? Sige. So, this will end up this video and I hope you learned something from this, no? So, if you haven't subscribed to our channel yet, please do subscribe and click the notification bell para ma-update kayo sa mga bagong tutorials natin. Okay? See you. Thank you.